Hello everyone, hope you're doing great. So you're welcome to my YouTube channel, NN Fabian Chemistry. If you've not yet subscribed, please do well to subscribe and turn on the notification button so that each time I upload a new video, you'll be the first person to know. So today we are to look at deriving the chemical formula of a compound. Usually, students face a lot of difficulties deriving chemical formulae of different compounds. And so today, that is our main topic of discussion. Now, before we continue, it is important we understand what a compound is. So what is a compound? A compound is simply a substance that is made up of two or more elements that are chemically bonded. A compound is simply a substance that is made up of two or more elements that are chemically bonded. Let's take, for example, the case of the compound sodium chloride. So, sodium chloride is a compound that is made up of two elements that are chemically bonded. We have sodium and chlorine. So, sodium chloride is an example of a compound. Now that we know what a compound is, I would like us to look at the second term, which is very important in today's lesson, and that is the term valency. What is a valency? A valency is simply the combining power of an atom or group of atoms. Valency is simply the combining power of an atom or group of atoms. In other words, a valency is the number of electrons an atom or group of atoms can use in bonding. If we have to write the formula of a compound correctly, we must be able to identify the valency of the element and use it appropriately. So let's see how we can identify the valencies of elements. By looking at the periodic table, it is pretty simple for us to identify the valency of elements. So here we have a periodic table. Let's take a look at it. This is our periodic table. On the periodic table, we have the elements arranged in groups, group 1 to 8. That is if we decide to ignore the transition series. So here we have group 1, group 2, we have group 3 over here, group 4, group 5, group 6, group 7, and group 8, often called group 0. Now, it is important for you to note that for elements that are in group 1 to group 4, their valency is the same as the group number. I repeat, for elements in group 1 to group 4, their valency is the same as the group number. So if we take, for example, the case of potassium, here we have potassium on the periodic table. So what is the valency of potassium? We can clearly see that potassium is in group 1. So it means the valency of potassium is 1. Let's take the case of aluminium. This is aluminium on the periodic table. What group? Group 3, right? So aluminium has a valency of 3. Now, for elements that are in group 5 to group 8, the valency is equal to 8 minus the group number. For elements in group 5 to 8, the valency is equal to 8 minus the group number. So let's take the case of nitrogen. What is the valency of nitrogen? Nitrogen is in group 5 of the periodic table. So the valency of nitrogen is equal to 8 minus 5, that is 3. Let's look at sulfur. Sulfur is in what group? Group 6, right? So what is the valency of sulfur? The valency for sulfur is 8 minus 6, that is 2. So that is how you can use the periodic table to identify the valency of an element. Note that there are, however, some elements that have more than one valency. We say they have variable valencies. We shall come across those cases. So let us look at a summary table that helps us. I think this table is pretty important to help us. So here we have group 1. Elements in group 1 have a valency of 1. Elements in group 2 have a valency of 2. Elements in group 3 have a valency of 3. Those in group 4 have a valency of 4. Elements in group 5 have a valency of 3. Elements in group 6 have a valency of 2. Elements in group 7 have a valency of 1. And elements in group 8, they do not have any valency. They have a valency of 0, right? And that is why group 8 elements hardly form compounds. Okay, that's said and done. Let us now look at some guidelines to writing or to deriving the chemical formula of a compound. In other words, what are some of the rules that we must follow each time we want to derive the chemical formula of a compound? So let's take a look at the rules here. Now, what does the first rule say? So we can clearly see, write the chemical symbols of the elements separately. That is the first thing we need to do, to write the chemical symbols of the elements separately. The next, we have to write the valency of each element underneath the symbol. Where possible, we should simplify the valencies. Take note of these rules because they're going to guide us as we derive the chemical formula of different compounds. After that, we interchange the valencies. And take note, the valencies are written as subscripts in front of the symbols of each element. The valency one is not written. So these are the rules we have to follow. Having these rules in mind, therefore, let us take a look at some examples. Okay, so let's look at some examples. Let us take this off. So the very first example I want us to look at is magnesium fluoride. So let us represent magnesium fluoride. That is it, magnesium fluoride. Are we there? So the first thing we need to do is to identify the elements which are present in this compound. Our compound is magnesium fluoride. So what are the elements? From the name, we can clearly see that magnesium is one of the elements and fluorine is the second element. So we have just two elements, magnesium and fluorine. So in case you don't know the chemical symbols of these elements, it is pretty simple. You just need to get to the periodic table and look up the symbols. So here we have our periodic table. Here we find magnesium. So the symbol of magnesium is uppercase M and lowercase g. Fluorine. Here we have fluorine, uppercase F. So now that we have the symbols of our elements, let us see how we can represent it. So here we go. Magnesium. So for magnesium, that is it. Fluorine is F. Now, what is the valency for magnesium? Let's go back to our periodic table. So if we look at the periodic table, you see that magnesium is in group 2. So what will be the valency of magnesium? Of course, it is 2. Now, what about fluorine? Let's look at fluorine. Fluorine is in group 7. So what will be the valency of fluorine? Take note, the valency of fluorine is not 7 in this case. It will be 8 minus 7, which is 1. So the valency of fluorine here is 1. Now, the second rule, remember, says we should write the valency of each element underneath the symbol. So for magnesium, we have 2. Magnesium, we have 2. And for fluorine, the valency is 1. Now, is it possible for us to simplify the valencies? Of course, it's not possible. So we move to the next rule, which says we should interchange the valencies. So we have to interchange the valencies. The valency of magnesium, we give it to fluorine, and the valency for fluorine, we give it to magnesium. So the formula, therefore, of our compound will be, we have magnesium. Remember, we do not represent 1 in the formula. So we shall just write magnesium fluoride F. So the 2 for magnesium now comes to fluorine. And that is the chemical formula of magnesium fluoride. Is that okay? Okay, let us look at a second example. This case, let's look at barium sulfide. Barium sulfide. Barium sulfide. Okay, here again, we need to identify the elements which are present in the compound barium fluoride. Now, just as the name indicates, we have barium and we have sulfur. Sulfide here represents sulfur. So we have barium and sulfur. So let's get to the periodic table to get the symbols of barium and sulfur. So here we have our periodic table. So this is it. Barium, here we find barium. Barium is in group 2, right? And that is the symbol for barium. So since barium is in group 2, what valency will it have? Of course, it will have a valency of 2. Now, here we have sulfur. Sulfur is in group 6 of the periodic table. Take note of the symbol. So what will be the valency of sulfur? It will be 8 minus 6, which is 2, right? So now we know the symbol of each of the elements as well as the valency. So let's go ahead and derive the chemical formula. So we have barium and we have sulfur. Barium has a valency of 2. Sulfur also has a valency of 2. Now, is it possible for us to simplify the valencies? Of course, it is possible. So we are going to simplify the valencies in this case. So we're going to simplify. Now we interchange the valencies. So what do we now have? Our formula, therefore, is barium BAS. So this is the chemical formula of barium sulfide. Hope it's okay. Let's look at one more example. This case, I want us to look at copper 2 chloride. Copper 2 chloride. So this is it. Copper 2 chloride. So we have copper 2 chloride. That is it. Copper 2 chloride. Now, what are the elements present in copper 2 chloride? What are the elements present in copper 2 chloride? we can clearly see that we have just two elements. We have copper and chlorine. So let's get to the periodic table to get the chemical symbol of each of the elements. So here we have our periodic table. So we have copper. This is the chemical symbol of copper, uppercase C and lowercase u. Let's get for chlorine as well. Chlorine is in group 7. So that is the symbol for chlorine. So what will be the valency of chlorine? It will, of course, be 8 minus 7, which is 1. Okay. So let's represent the chemical symbol for copper and chlorine. Now, what is the valency of copper? How can we get the valency of copper? If we look at the periodic table we have here, we cannot identify copper in any group. So this is it. So what is the valency of copper, therefore? It is pretty simple. Here we've been given the valency of copper. So the number which is represented in parentheses here represents the valency of copper. Copper is one of those elements that have more than one valency. So the valency we have to use in this case is the one indicated in parentheses. So what is it? It is 2. So the valency for copper in this case is 2. So let's represent it. It is 2. What about chlorine? We just saw for chlorine it is 1. Is this possible to simplify? Nope, it's not possible. So let us interchange the valencies. So when we interchange, we have this. So the formula, therefore, of copper 2 chloride is this. Formula or Cl2. That is the formula of copper 2 chloride. Now that we've done some examples, I want you to try some other ones. So I'm going to give you some few cases for you to derive the valency of the elements. So let's look at it. The first one is hydrogen bromide. So let's look at the first one, hydrogen bromide. The second, aluminium oxide. Aluminium oxide. The third, carbon 4 oxide. Carbon 4 oxide. And the very last example, potassium nitride. So go ahead and try these examples. Pause the video and try the examples, and when you're done, you come and continue. Okay, I suppose you've tried the 4 examples or the 4 exercises we have here. Now let's find out what we've done to see if it's correct. So let's begin with the very first case, which is hydrogen bromide. Okay, so hydrogen bromide. So for hydrogen bromide, what are the elements present? We can see we have 2 elements. We have hydrogen and bromine. So let's get to the periodic table to get the symbol of each of the elements. Here we have hydrogen and we have bromine. Bromine is in group 7 of the periodic table. Hydrogen has a valency of 1. What about bromine? What would be the valency of bromine? It will be 8 minus 7, that is 1. So here we go. Hydrogen bromide. So we have the symbol hydrogen and we have bromine. Hydrogen has a valency of 1, bromine has a valency of 1. So we interchange the valencies. What do we have? So it gives us the formula as HBr. So that is the chemical formula of hydrogen bromide. The second case is aluminum oxide. So let's look at it together. Aluminum oxide. So let's look at B. Aluminum oxide. So we have what elements? Aluminum and oxygen, right? So let's get to the periodic table again. Here we have aluminum and we have oxygen. So here we have aluminum and here we have oxygen. So aluminum is in what group? Group 3. Oxygen, what group? Group 6. So what will be the valency of oxygen? 8 minus 6, right? That is 2. And for aluminum, it will be 3. So let's represent each. Here we are, aluminum. So we have, that is for aluminum and oxygen. Aluminum has got a valency of 3 and oxygen has a valency of 2. So when we interchange the valencies, what do we have? Remember, in this case, it's not possible for us to simplify. So what do we have? We have the formula Al2O3. So that is the chemical formula of aluminum oxide. What is the next? The next is carbon 4 oxide. So take note, carbon can have more than one valency. So in this case, the valency we have to use has been indicated in parentheses. So it is 4. And we have oxygen. Those are the two elements. So let's derive for carbon 4 oxide. Carbon 4 oxide, also called carbon dioxide. So carbon, let's get to our periodic table. That is the symbol for carbon. We find it here. So here we have carbon and oxygen. We know the symbol already. So let's do it just like we did for the other cases. Carbon and we have oxygen. So the valency for carbon we have to use here is 4 as indicated in parentheses, and oxygen we know is in group 6, so the valency is 8 minus 6. That gives us 2. Now, is it possible for us to simplify? Of course it is possible. So we're going to simplify, and once that is done, it is possible for us to simplify. Here we have 2 and here we have 1. So we now interchange the valencies. When we interchange the valencies, what does the formula give us? So formula, we now have CO2. So that is it. And we this compound is commonly called carbon dioxide. The last case we have is potassium nitride. So let's see potassium nitride. potassium nitride. So what are the elements in the compound potassium nitride? We can clearly see that we have two elements. We have potassium and nitrogen. So let's get the symbol of potassium on the periodic table. It will be better if you can memorize some of these symbols so you won't have to look up the symbol at the periodic table each time. So here we have potassium. What group? In group 1, right? And the next is nitrogen. What group? Group 5. So what would be the valency for nitrogen? 8 minus 5, right? That is 3. And for potassium, what is the valency? It is 1, right? Okay. So let's see how we can do it. So potassium, we have, okay, and for nitrogen, okay, so potassium has a valency of 1, nitrogen has a valency of 3. Is it possible to simplify? Nope. So we interchange simply. So the formula, therefore, is K3N. Take note, in each case, I represent the number as a subscript. So that is the chemical formula of potassium nitride. So dear friends, that is it for deriving chemical formulae part 1. Part 2 will be coming up in the next video I'll upload. And in part 2, we shall be learning how to derive the chemical formula of compounds involving polyatomic ions. So please make sure you don't miss out on the part 2 of this lesson, deriving chemical formula of compounds. Remember to subscribe to our YouTube channel, NN Fabian Chemistry. So each time I upload a new video, you'll be the first to be notified. And as well, do well to leave your comments in the comments section below. Thank you so much for following the lesson and have a wonderful time. Bye-bye.